This is the Earth Science Classroom. When discussing the Pacific Ring of Fire, you must begin with the geography of the Pacific. It is such a large ocean. It's the biggest ocean on our planet and dwarfs the other oceans and even all the land masses combined. So the Earth has a combined surface area of around 197 million square miles. Of that 197, 63 million square miles is the Pacific Ocean. And that is around 31.98% of the total surface area of the Earth. And compared to other oceans, it is 45.2% of all the saltwater or oceans on our planet on the surface. So nearly half of all the oceans is the Pacific. The majority of the Pacific Ocean sits on the Pacific tectonic and lithospheric plate, which is oceanic, which means it is composed of mostly basalt by the surface, and as you go deeper down into the lithosphere, you get more peridotite, which is intrusive igneous rock, and basalt is extrusive igneous rock. Basalt has an average density of around 3 grams per centimeter cubed, and peridotite a little denser, between 3 to 3.4 grams per centimeter cubed. The starting point for the Pacific Plate is the divergent plate boundary, which is a combination of the Antarctic Pacific Rise and the East Pacific Rise, where you find the new oceanic crust and plate is being formed from the cooling of basaltic lava, and from there it is constructed and it moves across the Earth's surface as a unified plate under the influence of asthenospheric convection currents, moving at an average of 7 to 11 centimeters per year, which is equivalent to 3 to 4 inches per year, on its way across the surface of the Earth in a west and northwest direction, and it slows down towards the boundaries of these plates, and the thickness of this oceanic crust changes as well. It is thinner towards the divergent plate boundary, the East Pacific Rise, and the Antarctic Pacific Rise at around 35 miles in thickness, and it gets thicker progressively as it moves further away from the spreading center and extends to a max thickness of around 60 miles at the furthest point away from the divergent plate boundary or the spreading center. And the age ranges from brand new, newly formed lithospheric plate at the rise up to around 180 million years old at the very extremes of the edge of the Pacific Plate towards the far west of the Pacific Ocean. We have discussed the general tectonics and movement of the Pacific Plate. Now we're going to discuss the countries associated around the Pacific Rim or the Pacific Ring of Fire. Starting in the southern Pacific Ocean, around Oceania or Australasia, you got New Zealand, then Australia, Tonga, Fiji, the Solomon Islands, and Papua New Guinea. Then into Asia, looking at Indonesia, the Philippines, Taiwan, China, Japan, and Russia. Then looking into the northern part of the Pacific Ocean, looking at North America and Alaska, which is part of the US, Canada, back to the US with lower 48, and the West Coast, Mexico, and then into Central America, involving countries like Guatemala, El Salvador, Nicaragua, Costa Rica, and Panama. Then finally into South America, down the western coastline of South America, including Colombia, Ecuador, Peru, and finally Chile or Chile. The largest tectonic plate, the Pacific Plate, is an oceanic plate and is the center of the Pacific Ring of Fire, and how the edges of this oceanic plate meet and create boundaries with other plates, either continental or oceanic, to create the Pacific Ring of Fire. The major plates associated with the Ring of Fire are the Indo-Australian Plate, the Eurasian Plate, North American Plate, and South American Plate. And mixed in between, around the edges of the Pacific, in between these major plates, including the Pacific, are minor plates and microplates. The main minor plates include the Juan de Fuca, which could also be a microplate, the Cocos Plate, which is officially the coolest named plate on the planet, the Nazca Plate, the Scotia Plate, the Philippine Plate, and the Caribbean or Caribbean Plate. In order to complete the tectonic picture of the Pacific Ring of Fire, we must also include the Antarctic Plate, the circumpolar plate around the Antarctic continent, and it connects with the Indo-Australian Plate, the Pacific, the Nazca, South American, and the Scotia Plate around the Ring of Fire. Now, it's not actively involved with convergence. The Antarctic Plate creates a boundary with the other plates mentioned, forming a divergent plate boundary, a constructive plate margin, whereby the Pacific Plate is formed through the cooling basaltic lava and starts its journey across the Earth's surface to then collide and form convergent plate boundary and transform plate boundaries around the edge of the Pacific Ring of Fire. And this divergent plate boundary is split into two sections: the Pacific Antarctic Ridge and the East Pacific Rise. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth science, please check out my channel.